Folks, Segasonicfan here, and today I'm taking a look at the T-962A Reflow Oven. I made a couple videos some years ago, and I've learned a lot since then, especially because I've done some repairs on these, and I thought I'd share some of that knowledge with you lovely folks right now. I'm going to be doing a bunch of upgrades to this, but before I do all that, I'm going to document just some basic things I think everyone should really do if you have one of these. You've probably heard that there's a custom firmware that you can put on this original controller board, and that firmware is really cool, and I certainly recommend it. But I want to talk about just some basic safety stuff. So the biggest thing is that if you ever take this apart, you see here it says AC 9 volts. That's an alternating current 9 volt input, which gets converted to 12 volts DC, and then for the fan output here, for the case fan, the small one, the little tiny fan in the front of the case. And then it goes to this regulator to be converted into 5 volts for some of the circuits down here. And then it gets converted to 3.3 volts for your main microcontroller chip. Now this pin out, this connector here, which is the same connector, goes to your AC fan, like the big one on the back, which is actually partially tied to mains. And if you swap these plugs accidentally, which is very easy to do, they're the same color and the same plug and the same pins, you will, and I know this from experience, you will blow your bridge rectifier stage, you will blow this regulator, you will blow this regulator, and then you will blow your microcontroller. These will domino effect, and they will all break at the same time, and you will not be happy. I did replace one of these and reprogrammed it and replaced all of that stuff, and it was not fun. I did that on another board. So that's thing number one. Thing number two, this buzzer is annoying and loud. I generally hate these things in all electronics, always. Very rarely is there a use for them. So if you feel the same, you can remove, there's a little one transistor right here, and you just move that. I just have it kept on one of the pads, but it's completely disconnected from the circuit. That will make your buzzing go away. If your screen seems kind of dim or garbled, or not garbled, but kind of dim, or the contrast isn't the way you like it, this potentiometer here, this is a trim pot, and you can see I put some black hot glue here, but there's a, because I have it in the setting that I like, but there's a flathead opening there for your screwdriver. You can turn that, get your brighten, it's kind of a contrast brightness. You know how it is on those active matrix, those old school. I guess it is technically a TFT. Is it a TFT? No, it's an LCD. Anyway, these old displays, you know how it is. Sometimes you got to dial in the settings a bit. And then, of course, this is your SPI. This is your programming header for when you want to reprogram the microcontroller. There's lots of instructions on how to do that online. The one thing I will say is you want to make sure this is powered up before you program it. And if you're going to power it up before you program it, I would actually recommend taking it out of your unit like so, unscrewing everything, undoing the hot glue. Be careful of the keyboard cable. That's a little fragile, and you certainly don't want to break that one because that's really going to be a pain to take out if you do. But yeah, be careful of that one. And what was the other thing I had to be? Oh yes, you have to remove the hot glue and undo these 4 terminal block screws if you're going to take out the thermistor connectors, which I think you should do. And then you can get the whole board out like this. And this is a lot safer to work on because that, monstrosity of a case is just dangerous. It's not even grounded properly and is really hard to work with and heavy and big. So get the board out. And before you program, what I did at least, and you can try doing, is actually, and I believe this is the 5 volt. You can see I put some solder right here. But you can also just put it, one of these capacitors here. This is the 12 volt output capacitor for the, because that's the 12 volt fan. Yeah, you can find the 5 volt input, which, yeah, like I said, it's going to be, I believe it's right here. You can double check the 2 data sheets. Definitely double check the 2 data sheets. But you find the 5 volt input, which I believe is here, and then the ground, which is, the negative of any of these capacitors here. And then using your bench supply, a USB, whatever you want, give it 5 volts. give it 5 volts. That'll knock it down to 3.3, which will power your microcontroller. Then you can plug in your SPI bus. I recommend doing this because it's a much lower risk of anything bad happening. Like I said, the original setup is not properly grounded or isolated in any way, and certainly don't want people breaking their controller boards trying to upgrade the firmware. So I really recommend taking it out, giving it 5 volts. This is a 3.3 volt regulator. That's the main thing, and then you're good to go. Okay, next things. This is the cold junction temperature chip. What is it? The DB18 something Dallas and Maxim makes. There was a page I found online that said the Dallas chip actually needs 5 volts to one of these pins. So keep that in mind. I haven't run across that yet. But when you follow those instructions, you might want to look out for that. The center pin here goes to the pad on the right of this unpopulated setup here, and from what I understand, one of these goes to a GPIO, and one of them goes to a power rail, a 3.3 volt power rail, which is what, C20 right there is C20, I should say. And I can double check that really quick, but almost positive I got that right. But let's double check. Yeah. And a good place to grab power from, by the way, is this point right here, because that's the rail coming off. This is actually your 3.3 volts. This, I believe, is your ground. I believe this is your 5 volt in. I'm going to double check that. Yes. So, so yes, this is your 5 volt input. Let's go ahead and refocus the camera a bit here. Well, I gotta usually cover the lens to refocus it. All right, autofocusing technology, which doesn't always work in my favor. So yes, your 5 volts is here, 3.3 volts out, ground. And then you can use this miniature bypass cap for your 3.3 volt if you want, or you can use, I believe you can just use that as well. I'll double check for you right now. Yes, you can. So you can actually just grab 3.3 volt from here if that's easier. Needs your nice big solder point. But anyway, point is this is 3.3 volt, and then this is the a GPIO pin. So essentially this 4.7, this is a 4.7K resistor. It works as a pull-up. I guess that helps with the UART. This is a UART interface for that cold junction temperature mod. Looks like I got a scratch on here. I'm not sure when that happened. Yeah, so these microcontrollers are a little expensive now. They're getting harder to find. So you really want to be careful of this 3.3 volt rail. Part of me actually wants to make a overvoltage protection circuit, because that's what blows it up. Is you give this thing 5 volts or 12 volts or anything like that, it's going to die like that. There's no protection for overvoltage whatsoever. So yeah, if you really are nervous about that, I am to some. I mean, if I only had one of these, I would be very nervous about that. But I do have a spare, but still, it's not fun replacing that microcontroller and reprogramming it. What else? There is the fan upgrade for the front, the small. There's 2 fan upgrades actually. There's the front small fan upgrade, and then the control for the back fan. Small fan upgrade is this one. This is a 12 volt and ground socket, and what the upgrade has you do is use like an inline transistor or n-channel FET to and then hooking that up to AD0. You can see this is labeled here. It's an analog output, analog or digital output pin from the microcontroller, and then I guess they program the firmware to turn that fan on or off. A couple things I don't like about this. I mean, it is a simple mod, which is nice. A couple things I don't like about it. One is you have to like splice the cable or whatever, and I don't know where you're supposed to put that circuit. 2 is it's removing the ground reference for the fan, and I guess it's not too big of a deal if the fan's isolated, which it is. But I certainly would. I prefer to use P-channel FETs that I can PWM. I don't know if they're actually using a PWM in the code. That thing always just runs really loud for me, and it doesn't turn off when you apply power. I feel like that fan should be off when you boot up the system, because you don't, or boot up the oven. When the oven's off and booting up, that fan has that super loud, noisy fan does not need to be on. It only needs to turn on when the temperature rises. And as far as I know, the quote unquote upgraded firmware doesn't do that. It doesn't really help that much with that noise. And that built-in fan is really noisy. So you can also change the fan. From what I was reading from the GitHub, it's a 40 by 40 by 15 sized fan. So I might look for one of those. But in the meantime, the other thing I'm thinking of doing is just creating a circuit board that I would open source for this particular upgrade, just to make it a little easier for folks, because what you need is just two connectors, right? You just need a little board that can go right here, JST input, JST output, and then you can have your NPN there if you want, or something better. I am going to look into the firmware. I really don't want to be reprogramming this yet again. It's kind of a pain to do the whole firmware reprogramming. It's not the hardest thing ever, but you got to use your FTDI converter and everything. There's instructions for all that. But for completionist's sake, I should just show what I'm talking about. Where did I put this? So because the programming is actually over UART, if you want to program it with USB, you got to get yourself one of these boards. This is, I believe, called an FTDI converter, which takes the USB protocol and converts it into UART. Something like UART. Maybe it's not exactly UART because there's a TX and RX. But you can see here the labeling is god awful. You have to like kind of squint and look in between that jumper and these pins to see which pins are what. Yeah, I kind of just want to make a case for this and a better breakout for this guy to make my life easier. So I might do that and open source that as well. Yeah, like it would be nice to have a breakout, like a nice breakout connector for this guy with a case and everything to kind of go outside of the oven, so you can do firmware upgrades and all that kind of stuff, and you don't have to be taking apart that big heavy oven. You can just take a laptop over it, plug in a USB. That's something I would like very much, but we'll see what I have time for. So yeah, and then yeah, having that would be really nice with. And so here's the other cool part is actually someone came up with an Arduino like microcontroller solution for controlling the large AC fan, which is, I'm pointing at this plug, but actually that's not the fan plug, I think. This is the actual output to it, to the big AC fan. But what you can do is wire, there's a guide, which I'll try to link. I'll try to link all these guides below. But there are some pins here for the I/O for the fan, and power, and you just break those out to your favorite microcontroller. For me, it would just be an Arduino, an Atmega 328 or ATtiny. What's the new ATtiny 88? Be a good project for this. And then you use that to control the fan speed, so that you turn on the AC fan just a little bit when the oven is going, to reduce hot spots from the infrared, which will give you much better reflow results. At least that's what the inventor says. I believe it, because infrared creates hot spots, and if you don't have air circulation, it's a problem. And it creates more heat on black components like chips than before it creates heat on solder or copper. So that's also kind of an annoying thing about infrared, but it still does a pretty good job. And so, yeah, having those two fan controls would be really nice. What I might actually do is just use a single Arduino to control both. And I keep pointing at this, but that is not, I don't believe that's the fan. That's the output for the solid state relay, which I guess actually, you know what? No, the solid state relay does it control the fan and the oven, or just the fan, or just the oven, I mean. I'll have to double check on that. I'll have to look at the schematics, because you have your fan output here. This is the solid state relay. This is your AC in, for mains AC in. This is your 9-volt AC in, because there's a tiny little transformer in the back of the case. And that's all it is, right? It's really janky that you get mains to a transformer, and then it goes here, and then it's relying on everything else happening here. And that's why it's so easy to blow it up. It's not an actual enclosed whatever good power circuit. AC to DC power circuit. So yeah, I'm thinking I might do a microcontroller solution, because then I can do I think I could do a fan control from there. or I'm sorry, that's the solid, that's the solid state relay. This is the fan, and then I have to tap the points on the bottom for the case fan, the large case fan, the AC fan. So yeah, get this to a microcontroller, and I'll post back. I'm gonna do another follow-up on this guy. I'll see what I can get done. I have a lot of other projects, a lot of other things to do, but I would really like a reliable reflow oven so I can populate circuits here, populate boards without too much headache. And these T962As, they have a ton of problems. They're janky, but in a lot of cases they get the job done, and they're still by far the only affordable option available right now for reflow ovens, as far as I know. If you know a reflow oven that's in the $200 to $400 range, that is newer than this, better than this, which really is basically anything, because these are bottom of the barrel, do let me know, because I would love to upgrade at some point. And in the meantime, for all you out there hacking and upgrading these, hopefully this video has been helpful. You can find full schematics of these, which I will also try to link. Feel free to remind me if I forget something in the description. And love to hear comments and stuff from folks. Oh, one last thing I'll say, because I didn't go over the display stuff. Actually, this is really important. I was gonna wind down my video here, but I forgot. There is the display. And by the way, when I blew up the whole thing here by swapping these cables accidentally, I also blew up my display board. And this is the old display board. You can see I actually added a 2.54 millimeter pin header. Now originally there's this connector goes to just bare wires that are soldered directly to this thing, which is dumb. In my opinion, because then you have these really loose connections that are easy to break. And you can't easily just remove the screen. You have to unplug this, and then you have all these wires that are kind of hanging down by the connector, and again, they break easily. So very important thing about this screen, there's a bunch of these out here, and it took me way too long to find a solid replacement that actually worked, because there's so many variants of these 128, I think it's a 128 by 64 LCD screen. And you get these on AliExpress, Alibaba, but there are sellers on eBay as well for replacement ones of these, because they're used in so many projects. What you'll notice about this one, though, is no markings. And these numbers aren't going to help you too much either. What I ended up doing, which was a total lifesaver, was looking at the Swedish upgraded firmware. And these guys saved my butt, because they mention in the firmware code the driver that the screen uses, and that clued me in to get the correct one, which I have two now. I have this one I just got, which I'm fairly confident is going to work fine. Yeah, it's 128. You can see that the numbers are different, but this one actually has a pinout. Yay! And the important thing is you want to get the one that has, and I forget the exact part number, it's like the driver number. But basically, there's a driver chip in here that's specific to this board. And so even though these something like this might look really similar, it won't work. And you might find ones that have the blobs in the same place that still won't work. You have to have the same driver chip that supports this CS1, CS2. And that is I think it's a chip select, actually, that displays certain segments of the screen. So if you use the incorrect screen like this one, it won't break your microcontroller. At least it didn't for me, because you see you have this PSB instead and then no connection. But what it will do is display like half of a garbled screen, which is useful. It was useful for me when I was debugging. But this is totally incompatible, and there's no way to like modify that. It's the actual controller chip in one of these blobs. So yeah, it's like the KS700 or something like that. Again, I'll post in the description those kind of details. Remind me if I forget. These videos are free. I'm volunteering my time to help people, so please be nice. But yeah, you want to look out for that correct screen controller. This screen, by the way, is an upgrade in my opinion, because it's going to be a white on black, which should be very, very visible, and hopefully looks a little nicer than the blue and white ones, which, they're okay. But kind of looking forward to seeing what that looks like. And again, that's the other advantage of doing that pin header, adding a pin header like this, is you can swap out screens easily should you, I don't know, drop your soldering iron on one like I did years ago. Don't tell anyone. These things have seen a lot of use for me, and that's why I want to give them some care. So last thing I think I can add to this video is I'm going to be replacing this AC input, this 9 volt AC input, which is super prone to shorting everything out, with a JST XH-2 connector, which I believe is going to be about the same pin width. And if not, I'll yeah, it's about the same. I'll see what I can do. But I'm going to do that with this cable, which I'm going to heat shrink and, connect to the AC that comes in, the low voltage AC. And that will make it so that I can never, ever, ever swap this cable with this cable. I might even include an inline Pico fuse because I love to do that. It's good protection. Once you do that, you're highly recommended. You'll have your microcontroller safe. And then, yeah, I'll let you know if I decide to make a breakout board. I definitely plan on open sourcing anything I make for this because it's an open source like community thing overall. People have been open sourcing the firmware and everything else. So the least I could do is open source some small PCBs that I'll design. Let me know if you're interested in that. It's great to hear from folks. I'll try to put credits for all the folks that have done the work that came before me. Very important. Give credit where credit is due. Super nice people to provide the info that has helped me up to this point. And so I'm just trying to take it a couple steps further. That's it for this video. More to come on these crazy ovens. This is Segasonicfan, signing out.